region we are going to talk about is the complete neutralization region, okay? Otherwise known as the equivalence point. Okay, so equivalence point is where complete neutralization occurs. Okay, so I'm going to write all that down for you to take note right in your summary. Okay, guys, this is very important. You must know that equivalence point always occurs at the complete neutralization. Now, before you even start, I need you guys to have a rough idea of how the curve will look like. And you can deduce how the curve will look like because we know that as we add base to acids, the pH will start to slowly increase. And there will be a point where the acid and the base will completely react with one another. Now, let me write that equation down. Ethanoic acid is a monobasic acid. So that means it will react on a 1:1 ratio with NaOH. And neutralization means it is an irreversible arrow. And we will get salt. And we will get water. This is the equation that is happening throughout the entire experiment. And guys, what we are going to do is this. We are going to try to find where complete neutralization will occur. And it's pretty easy, right? Because you can see that these two react on a 1:1 ratio. If you want the complete neutralization, all you need to do is to do a mole ratio of our ethanoic acid and NaOH. And you can look immediately that since the concentration is the same, and they react on a 1:1 ratio, that means that the volume of NaOH to react must also be 25 cm3. Okay, let me show it to you. Over here, I'm going to try to find what is the amount needed for complete neutralization. We are going to convert ethanoic acid into moles. So 25 cm3 divided by 1000 times 0.1. Okay, if you punch that into the calculator, you'll get 0.0025. So if I want complete neutralization, I need 0.0025 of NaOH. Now, if you convert these moles back into volume by dividing with this concentration, you will get 25 cm3. Okay, so I need you guys to go and do this first. Okay, you must find out where the equivalence point is. And the equivalence point is where complete neutralization occurs. You need to write this down because it will guide you when you draw the curve. So the pH will climb, and the moment you reach complete neutralization or equivalence point, the pH will spike. And we'll do a sharp spike, and then after the initial sharp spike, it will plateau and it will slowly continue to increase. So you need to have a rough frame of the titration curve that you are drawing. Okay? You must understand the overview of what you are doing before diving into the details. Now we are going to dive into the detail. What the question will want is ask you, what the question will want is they want you to calculate the pH of the equivalence point, which is basically the center region of the sharp spike. So they want you to find out what the pH is. And this part is a salt hydrolysis question. Let me repeat that one more time because this is so important. At the equivalence point, if a question asks you to calculate the pH at the equivalence point, that is complete neutralization. And when you have complete neutralization, that is a salt hydrolysis question. Guys, you can drill this into your head. Equivalence point question is always a salt hydrolysis question. Okay? And when do you know it is equivalence point? When the acid and the base react on a 1:1 ratio. And I say this multiple times. You do salt hydrolysis when there is no acid and no base left after the reaction. And the only thing left inside your solution is your salt. Okay? So if I write the ICE table, this is how the situation currently looks like after the reaction. Okay? And guys, this ICE table is in terms of moles. Okay? So you see the acid and the base? They are 0. After the reaction, there is no acid, no base left. The only thing left with is the salt. Now, at this point, you must be able to identify whether something can go through salt hydrolysis or not. All right? If you cannot do that, then you must go back and revise that topic. But if you have done that, you will realize that sodium ethanoate can go through salt hydrolysis because inside sodium ethanoate, you have ethanoate. And ethanoate is a conjugate base of ethanoic acid. So it will react with water to produce OH minus because ethanoate is a conjugate base. Conjugate base will produce OH minus. And this is a reversible reaction because this is a hydrolysis equation. Ethanoate is still a weak base. Now, what we are going to do next is, in order to find the pH here, we need to find out what is the OH minus concentration. Because this is a base calculation question. We will never get the H plus calculation. We must find out what the pH by using the relationship of pH and pOH. So remember, pH and pOH is equal to 14 at 25 degrees. So that means that if I am looking for the pH, I can find what is the pH by finding what is the value of the pOH. And we all know that pOH is given by negative log of the OH minus concentration. So we need to solve what is the OH minus concentration that is coming from our salt over here. So the second ICE table that we are going to draw have a purpose. And that purpose is to calculate the OH minus concentration. So this ICE table must be in concentration. So I am going to put in the concentration of our ethanoate. And I will put in 0.0025 because that is the moles of ethanoate that we have found. And I will divide it by the total volume. Now, guys, please take note, the total volume is the total volume, meaning it consists of the base volume, which is 25, plus the original acid volume, which is also 25. So your total volume must be 25 plus 25. You convert it to dm cube, multiply by 1000, and this will give you your concentration, and that will be 0.05. So this is your ethanoate concentration. And guys, this is just going to be a base calculation because ethanoate is a weak base. So I'm going to just fill it as per normal. Minus x here, plus x here, plus x here. 0.05 minus x, x here, x here. And I always ask my students this, do you need Ka or Kb to solve? This is a base dissociation equation. So you need the Kb of ethanoate to solve. So I'm going to write the Kb equation first. Okay, so Kb is products divided by the reactant. Okay, no water. Now, let's look at the question. There is no Ka, there's no Kb given. They give us Ka instead. Now, guys, this is a very common trick, okay? But that will not stop us because we know that Ka and Kb of conjugates are related. Ka times Kb is equal to the Kw. Okay? So you can find out what the Kb of ethanoate is using the Ka of ethanoic acid. By simple manipulation, you can take Kw and you divide it by the Ka of ethanoate. We are going to put in the x values. X, 0.05 minus x. And you can solve because Kw is a constant value. You must memorize this is in the data booklet. Ka is given to us in the question. Okay, you can solve for what is that x value, and your x value over here will be the OH minus concentration. Okay, solve for x. X is our OH minus concentration. Ka multiplied by 0.05. Over here, this is just 0.05, okay? And you solve the rest, okay? And you will get the final answer, which is 8.72. This is a salt hydrolysis question, guys. A salt hydrolysis question is the most tedious in the entire titration curve, but you must be able to do that, Okay, because it's a 3-mark question. If you cannot do that, you are not giving yourself any chance in a titration curve. Okay, so please practice this. This is the simplest and the clearest way of presenting our soil hydrolysis. If you can follow and you can do as I just did it, I guarantee you, you will always get full marks. Okay?